So good day guys. So what we are doing now is equilibrium constant. So how to find equilibrium constant. So if you are new to this channel, endeavor to subscribe to my YouTube channel and click on the notification icon so that when I drop interesting video like this, you will have access to it. So without wasting much of our time, let's dive into our main aspect. So what we are doing now is finding equilibrium constant. So we have N2O4 in gas phase, a forward and backward reaction. That's a reversible reaction. 2N2O, 2NO2 in also in gas phase. In the reaction above, the equilibrium constant is what? So when you have questions like this, let me explain in the next slide. Whenever you have a question like this, that's if you have a compound like this, let me use another color. If you have a compound like this plus B, and you have forward and backward reaction, and you have C, let me write it, you have CC plus DD. Hope you understand. Whenever they ask you to find equilibrium constant, the first thing for you to consider is that all of them must be in what? Gas phase. I hope you understand. If you want to include them in equilibrium constant, so for me to find the equilibrium constant here, it is going to be these products. For forward reaction, it will be what? Because we have two types of equilibrium constant formula, so these questions, what they're asking us to find is that of, whenever they don't specify that if it is forward or backward reaction, in this question they didn't specify for us, that is, they didn't say if it's for forward reaction or backward reaction. So whenever they don't specify like that, you are going to apply forward approach for it. So now for this one, now you are going to use forward approach for it. So all of them are in gas phase. You just do is that this product, you know that this product and this is the reactant, so this product will be at the top. So this is how you write it. You write it like CC, and this C at the mole position is going to be on the top like this, and this D, it will be here, and this G will be on the top. Similarly, the way you did this, your reactant will be at the denominator and your product will be at the what? The numerator. So your reactants will be at the what? Denominator. So you now be A raised to power what? A, and B raised to power B. I hope you understand. But if one of the reactants, maybe it is solid, you will not include it in your equilibrium constant. That is, if this B is in solid state, you will just remove this B. You will not include it. You just remove it. I hope you understand the approach. And also, if this A here is in solid state, you will not include it there. You will not include it. That is, you just write the equilibrium constant like this. I hope you get the approach. So all of them must be in gas phase before you can put them in equilibrium constant. So for this type of question, so if you don't understand the explanation, you can go through the video again. So if you see it now, both of them here, they are what? They are both in what? Gas state. So that's why we must include both of them in the equilibrium constant. So now let's write the equilibrium constant on the next slide. So we have N2O4 forward backward reaction, both in gas phase. We have NO2, we have 2. So now for you to write equilibrium constant for this question, it's going to be, you know that this 2 is representing just small letter C, and this OLO2 is representing what? Capital letter C. Just like, but this one, if you look at this one, there's nothing like number of mole in this side, so the number of mole here is just 1. I hope you understand. So for you to now write it will now be what? For you to write the equilibrium constant, it will be Kc will now be what? It will now be the product over the reactant. It will now be NO2 raised to power what? Raised to power 2 over N2O4. So this is how to find equilibrium constant. So I hope you understand. So it is very simple if you can know the approach. So for it. And don't forget, before you can include a substance in a equilibrium constant, it must be in what? Gas phase. So I hope you understand. So that's that for this video. Please endeavor to subscribe to my YouTube channel so that you can have access to interesting video like this. So bye.